Clarus Cable. And so chat whenever and something comes up, let me know. And so we'll go ahead and move forward. So now we have Clarus cables, Clarus audio cables, what we believe is the new high-end standard. That's what we're getting from our dealers and distributors and end users that are coming back with an incredible, wow, these are fabulous cables. They comparing them to other cables of same amount, whether it's AudioQuest, whether it's Wire World or Nordost, or any of the higher end cables. People are coming back to us and saying, wow, they really are great. We really are enjoying them and the improvement over their previous ownership. So that's worked out really well. So when we talk about the cables, when we talk about the these kinds of cables, in fact, I gotta change something over here too. Okay, so we're gonna do this and that. So when we talk about Clarus cables, and we're talking about really anything that we're sending on any of these high-end goods, we really have to have our story. We have to have something that we talk about that is a story about the product, how it was developed, maybe the technology, how you came across it yourself, what was the aha, how did you find it? And Clarus has got absolutely a great story. And the technology also goes right along with that, right along with that story. So we talk about that. You know, it's the whole program, the whole product line of Clarus is a result of Jay Victor's accomplishment. Jay Victor is the designer, and he holds the patents. He came up with a patent on the idea, and I'll discuss the idea with you on these cables. And then we became a licensee of those patents, and we produce the product and we market it and sell it. So Jay Victor is responsible for this, and he has really a remarkable journey of scientific curiosity, what I call scientific curiosity, engineering, and persistence, and to accomplish what he was trying to do, and that was to create the finest audio cables, the world's finest audio cables. And Clarus certainly is right up there. It's absolutely a fabulous cable. But, you know, Jay's over 50 years of cable technology patents that he owns and he has, and that background is phenomenal. Those patents, I did not know anything about these patents that he owned, and I was working with Jay back in 2000, and I think it was about 2005 when he first came to us. 2005, maybe it was 2007 that he came to us and had the idea of helping us with our power conditioning. At that time, we were having power conditioners made here in Florida that we designed, and they were made for us here. I think one was a TX500, and it was quite expensive because it was being made here, so it was really expensive to make, expensive to sell. And Jay helped us come up with a follow-up product, which was our TX100 and T100 and T200. And those we had made in China, and basically with a company that he worked with there. And he helped us with the design and also getting it manufactured, which worked out to be fabulous. We sold tens of thousands of those, and I think we got 4 or 5 back actually that had any kind of problems with us. So they were bulletproof products. They were really great. And unfortunately, we had to stop selling them because the cost went through the roof. However, getting to know Jay, I had discussed with him a meeting that I had with John Atkinson, who at the time was the chief editor or editor-in-chief of Stereophile magazine. I had met him in New York on a press tour, and when I was introduced, he said, "Oh yeah, Tributaries, you guys make home theater cables." Now, this is before Clarus. And so that was kind of a little bit of a rap on the knuckle to home theater cables, eh? So we did not have any kind of credibility with the high-end guys for Tributaries cables. Even though we sold expensive cables, they were not considered high-end or serious audio cables. And Jay then introduced me to his patents. And one of the patents in particular was the one we'll be talking about today and the one on which Clarus is based. And that got my attention. I mean, I have an engineering degree, so when we talk about wire and cable and high-end sound and all these other things, you know, when you get into thousands of dollars, always took this with a kind of a grain of salt. But when I heard what he was doing and listened to the product, I was just phenomenal. I couldn't believe how much of a difference there was with these cables. So that got me involved. And, you know, looking back now at what Jay did and how he did it, it was really amazing because I know from my own experience, if I go to any of my cable suppliers, my manufacturers, and I go to them and say, hey, I have this new cable I want you to make for me, and here's the drawing of it, all the different conductors and insulators, dielectrics, shielding, whatever. And they say, no problem, Joe, we can do that, 5,000 meters minimum first order, and you have to pay all the startup costs. Well, in terms of Clarus, that could be $30,000 or $40,000. Well, as something that you're developing and you need a sample, a first sample, that's an incredible amount of money to spend. And you know, for normal people who don't have the kind of connection that Jay had, that it would be impossible. But Jay had the connection with a state-of-the-art cable manufacturing company in China that he had worked with before, and they will made smaller runs for him, 100-meter runs, one roll, and he could then cut that up and do his samples. And that's really what was where he was able to get this done. Give you an idea of what it took to do it. That cable manufacturing plant gave him the ability and the freedom to produce, innovate, test, and improve the cable designs through hundreds of different iterations. 10 years of development went into this. Jay, in one of the videos I'll be showing you, Jay will take you back and give you an idea of how he started it and what got him started in this quest that he had to develop this cable. And once he had come across this particular fact of the wire size and shapes and what a difference it made, it set him on this course of designing Clarus cables. Well, that development again took 10 years, and it's an amazing discovery, an amazing development. And all the parts and pieces that go into Clarus cables are unique. They're all made and designed by us for us. So they're all our particular pieces, all the connectors, all the internal parts, all the jacketing, the breakouts, the silicon tubes, everything in that cable is proprietary. Everything is ours. And took a lot of time and effort and resources to make that happen, but the product definitely was worth it. So we have all these different pieces made, and then we bring them into Orlando and we do all our assemblies here. So all our soldering, prepping, testing, everything gets done in Orlando, and then we package it, of course, and we ship it from here, so, and test it. So that's basically the whole concept for our Clarus cables and how that got started. So here's something from Jay. I want to share a video with you. And this has to do with Jay and his background.
Hello, I'm Jay Victor. I am an audio designer. I started out in the wire and cable design area.
Whoop, sorry, that was me.
In the mid-1980s, eventually moving on to audio cable designs, and I've done OEM design work and consulting for many different well-known audio companies. I began working with tributaries in 2003, and we initially worked together on power conditioners. Later we went into HDMI cables and other types of cables, and Clarus began in 2013. The design goals for Clarus were to come up with a line of cables that were neutral, that didn't impose any particular frequency balance or editorialize the sound in any way. We wanted a neutral cable that represented accurately as possible the sound of live music, and also what's on the original recording. To date, we have two lines of Clarus cables, AQUA and Crimson, with Crimson being the flagship cable line. And these cables were designed specifically for particular applications. There's separate designs for the audio interconnects, separate designs for subwoofer power cables. The goal is always to be as neutral as possible. Clarus is about a natural sounding, accurate cable that doesn't editorialize.
So there you got an idea from Jay, a little bit about his style and his development process. So what he was talking about is seeking neutrality. I mean, a cable designer, that's the whole concept. How do you get a signal through a piece of wire from beginning to end, from the source to the sink without any change? Well, that's impossible. There's always going to be some change. It's a wire, and wire or cable has inductance, capacitance, and resistance, altogether known as impedance. And that impedance is always trying to change the signal. It's either going to hold it back or it's going to change the response. It's going to maybe lower the high frequency response and raise the bass, or raise the bass and lower the highs. Something will happen to it depending upon those parameters of inductance, capacitance, and resistance. And there's also noise. Noise is induced into the cable, and that can come from the inside the house in the grid, or can come from outside. And RF can be induced into the cable lines. And the idea is, how do you get rid of that noise? The whole basic design of these cables is, how are they designed, or can they be designed to lower the noise floor as much as possible and make the cable as smooth or flat in frequency response as possible. And the crux of Jay's design, the whole center point of the design, is that the Clarus design smooths out the cable frequency response through the use of proprietary cable shapes and sizes that are designed to influence specific frequency ranges. So shapes and sizes for specific frequency ranges. That's the crux of the design. So Jay came up, we figured out how to do that. What shapes, what sizes, how many? And he put that all together to come up with this fabulous design in Clarus Cable. Now, he also came up with some really interesting winding methods of how to wind the copper in the cable in these different topologies so that it reduces noise, using the concepts that you're very used to with Category 5 wire, Category 6 wire, where the windings can reduce the noise or eliminate noise in a lot of cases, is also used in all our cables, all our Clarus cables. So it was a very important development. So let's see. Let's talk about the next visit with Jay. And that's the history of his design. So here's a discussion of his actual history in the designing of Clarus cables. This is kind of fun to. All these videos are short. They're only a couple of minutes long, and they have a very specific topic, and I think you'll enjoy it.
So the history and process of designing Clarus cables goes back to 2002, when I first began working with a Chinese cable factory. And essentially, after proving myself to them and solving some production problems, and they knew that I had come from Monster, and they had some level of confidence in me, I pretty much had the factory at my disposal. And one of the first things that I did was I noticed that they had a lot of different size flat conductors that they had been manufacturing for various projects. And I was very curious about how they would sound. So I made up some interconnects just using a flat conductor, just to get an idea of what a flat conductor sounds like. To go into a little bit of how a cable designer becomes a cable designer, one of the first things you do, generally speaking, is you start to listen to every different possible conductor gauge. And these are going to be round cables, basically, round wires, I should say. And every different gauge has a different tonal balance if you listen to them all. So then what you arrive at, generally speaking, is a multi-conductor cable, such as pretty much everything on the market, where you have a lot of different gauges to carry different frequency ranges or to adjust the tonal balance so that it becomes accurate. So with a flat conductor, what I found was that it reproduced the mid-range better than anything I had ever heard before, but it had pretty much no low frequencies and pretty much no high frequencies. But the mid-range was so good that it really started a thought process in terms of, okay, how can I use this with other types of conductors to get full range instead of just mid-range? The base conductor part was fairly simple because I think pretty much everybody knows, or every cable designer knows, that a large conventional conductor will support low frequencies and reproduce them rather well. So adding some low frequency round solid conductors to the flat conductor gave me base and mid-range, but relatively little in the way of high frequencies. That pretty much gave me quite a bit of time to think about what's the ideal high-frequency conductor. And generally speaking, people will use very fine gauge conductors for this, but the problem is they all need insulation because you don't want stranded wire in a high-end audio cable. So that's a difficult process to achieve, or to do right, because you have too much insulation in there. So then it occurred to me that since high frequencies travel on the surface of a conductor due to skin effect, the ideal conductor would be just a surface. A thin tube doesn't really work because you can't bend it. And then it occurred to me, and because of being in the wire industry and knowing the trade rather well, I knew of a type of conductor that's largely obsolete today that's generally called tinsel wire, and it had been used in phone cords back when we had landlines and analog phones that had a coiled cord between the handset and the part that was either sitting on your desk or mounted on the wall. That was what that was primarily used for, and it's pretty much obsolete. Nobody makes that anymore. And there's one or two companies that do make it, but I found them to be uncooperative in terms of using audiophile materials, so we essentially had to buy the machinery to make this type of conductor with audiophile grade materials like higher grade copper, and the center core essentially in these phone cord kind of cables was usually nylon, which is horrible for audio. So basically it's a thin foil spiral wrapped around a non-conductive core, and in most cases that was a solid core, which also was no good. So we had to come up with a way of using PE fibers for the core, and then wrapping a high-grade copper foil around it and then insulation over that. So that gave us the high frequencies. So the rest of the whole art of this was in figuring out how many solid conductors and what gauges with a flat conductor, and then how many spiral ribbon conductors would result in a fully balanced sounding cable. It took many years to finalize that and to perfect it. There were a lot of samples made, a lot of trial and error, and it went on for about 10 years, really, before it got distilled down to what Clarus is today. And that's essentially the history of it.
So that pretty well sums up how he did that, and that whole concept. It's all based on what's called skin effect. Skin effect is an engineering term, and it has to do with how a signal travels through a conductor, and that where it travels in the conductor is based heavily on the frequency of that signal. So as the frequency increases, that signal tends to move out to the surface, and the lower frequency tends to be more evenly distributed throughout the cross-sectional area of the conductor. And Jay just developed his product based on that whole concept of how that signal works. So if you look at, he found that the high frequencies really like a thin tube. So it's hollow in the middle, that has an outside surface area, and it also has an inside surface area. So it has a lot of surface area to it, and it also it's very thin. So it doesn't have a lot of cross-sectional area. And what Jay found was that high frequencies tend to favor that kind of a conductor. Then the low frequencies, which is pretty well known already, tend to favor solid conductors. So if we take a solid round conductor, they'll always have a good bass response. Mid-range, not so much, high frequencies, not so much, but the bass will be there. And the other one, the big aha, was the flat wire, and that is having a flat conductor that has a lot of surface area, but also has some cross-sectional area. So it has some thickness to it. And with that thickness and high cross-sectional area, the mid-frequencies tend to like that. And if you take a Clarus cable and you take it apart and open it, one of the things you'll find is there's one flat wire that runs through the whole cable. It's a thick, flat wire, and that one is really the mid-range control. Now, it's not a crossover, so it does not like their specific frequencies. It's more that certain frequencies will conduct better on certain conductors than others, so they'll travel easier. So it's kind of like water is going to find this lowest path of resistance. Well, that seems to be the case for this too. So so that's where the whole concept is based on, this idea, and he's proven this out in listening tests. So empirically, by just listening to these. So now I want to share with you Jay's discussion on his patents, on the actual patents that he has and how those work.
The Clarus patents basically involve different shapes of conductors rather than just different conductor gauges like most other high-end audio cables. Essentially, there's a flat conductor for mid-range, large solid conductors for bass, and hollow or spiral ribbon conductors with a non-conductive core for high frequencies. The patents basically cover a combination of any two of these conductor types, with a fourth type actually being Litz wire, which isn't used in the audio cables, but it's used in some of the other cables. Essentially, the reasons for this is skin effect, which pretty much everybody has heard of. Essentially, different frequencies travel at different depths through a conductor. And when you have a thin, flat conductor, as opposed to a round, solid conductor, you don't have a lot of skin depth. So essentially, you can't support low frequencies. And because you have a dielectric material around it, it rolls off the high frequencies because it's high capacitance. So when you combine that with solid conductors that support the base and hollow conductors, because high frequencies travel on the surface, you end up with a full range cable. The hollow conductors, essentially you can't have a tube because it wouldn't be flexible. So the answer to that is to spiral a very, very thin copper foil around a non-conductive core, which approximates a tube, and then put insulation over that. So essentially the patents say that you're going to use any combination of 2 or more conductor shapes to give a fully balanced cable in terms of frequency range. So essentially, it's different shapes of conductors optimized for frequency ranges, as opposed to just solid or stranded conductors that only differ in the wire gauge itself.
Now, so that's all about the patents. And now we want to look at the final process for Jay, and that is the voicing. Now, most of you know about voicing rooms, so that you can tune the room to the specific speakers that you're using, but there's also the process of voicing the cables. Now, of course, that has to be done by the designer, and Jay talks about how he voiced these cables, which I thought was fascinating. I've never thought about the idea that you would voice a cable. So here's Jay's discussion of that.
The sonic goals of Clarus cables gets into the voicing of audio cables, which is something that nobody ever really talks about in my experience. Essentially, I have a long history of listening to live music. I was a subscriber at the old Carnegie Hall, and I have a very good sonic memory in terms of what things sound like. I'm also a musician, so I'm very sensitive to what does live music sound like in a live space. I think frequently a lot of audio designers seek to give you an exaggerated hi-fi kind of sense to the sound, but to me that's just not accurate. So my goal is and always has been to come up with designs that are basically neutral. I want to just communicate whatever was on the recording through the cable and to the electronics, the speakers, whatever, but I don't think that the cable itself should have any particular variation or impose any particular variation on the signal that's there. So essentially, I'm looking for a natural, neutral sounding cable that accurately produces the sound of live music. One of the things I do to achieve that is any prototype cables I'll listen to through a number of different systems so that I'm sure that the sound of the cable itself isn't really changing the sound quality. And the only way to do that really is to use live music as a reference, and also a number of different audio systems that you're very familiar with, so that you understand what the normal sound is of a particular recording. Unless you were in the recording studio when that recording was made, you never really know. So you can only get an approximation of that by listening to these things under many different circumstances and conditions. So eventually you arrive at a composite picture of what it's supposed to sound like. And it's only then that you can determine whether the cable is imparting any particular sonic signature of its own. And to me, that's something to be avoided And when I do the voicing and listening tests of the cable, that is the goal, really, is to achieve neutrality as much as possible. Now, some have said that the Clarus cables are a little bit forward sounding in the mid-range, but I would argue that that is the natural sound of most music, because the human ear is most sensitive in the mid-range. And if you get it right, it might seem to be a little bit forward, but I think it's accurate. So essentially, the goal of the Clarus cables and the voicing of them is geared towards neutrality rather than exaggerating high frequencies for impact or low frequencies or what have you. It's not to make a more impressive demonstration. It's really to get out of the way and to just let the music be as it was recorded.
Jay is really something. He's one of the few guys that I've run into that are at this level of cable design that can accurately discuss what they're doing and how they do it in terms that are understandable. I mean, that's just so rare. Most of these guys that do this, when you talk about their design, they really don't want to talk about it. And if they do, they talk about it in terms that it's really hard to understand what it is that they're talking about. So let's talk about a little bit more about the cables now, and we'll talk about the new addition to the line, and that is the Mark II, the Clarus Mark II. And these cables, let's go back to sharing the screen again. These Clarus cables Mark II, the cables haven't changed. The cabling itself, the wire and the cable, is the same. What we've changed are the connectors, XLRs, RCAs, spade lugs, and banana plugs. They're all new from a new company, so it's a new look and actually has some really neat features to it. And first one let's talk about is the AQUA RCAs. So these are the single-ended RCA. So now one of the things that jumps right out, the first thing you see is the hollow center pin. Well, that hollow center pin is an interesting development, and it has to do with something called eddy currents. What we found is that solid core doesn't sound quite as good as a hollow core center pin, and the reason is something that we believe it's caused by eddy currents. Eddy currents are currents that are flowing in the opposite direction as the signal is increasing and decreasing. The musical signal is increasing and decreasing. These opposite currents are being formed, and they're very small, but they do have a very slight effect on the sound. So these hollow tubes actually sound better. The other thing that we've changed are the composition, the metal. We used to use all our connectors were brass connectors. And now we've changed it to a copper alloy. And we use two different kinds of copper alloys, tellurium and beryllium. And they're both alloys and they have their different characteristics. The tellurium copper is important because what it does is it gives the copper, pure copper, strength. Copper itself is very ductile. It can be bent or change shaped easily. It's soft. Adding tellurium to it hardens it up and makes it a nice, firm, hard structure, so that center pin, when it's pushed into the connector, it will maintain its form and its shape and have good contact with the internal receptacle, and also have great conductivity and maintain that conductivity. The ground contacts, we're using beryllium copper. Now, beryllium copper is different in that not only does it add the strength to it, but it also adds springiness to it. In other words, it has a memory. So if you bend it, it's going to want to go back to its original shape, which is perfect for the ground contacts on that RCA connector, because as you're plugging something in, if if you plug it in and the ground contacts just make contact and they open up and they just stay in that one position, there's not going to be a lot of contact pressure between the two. But because it wants to go back to its original position, it's going to press down and it's going to increase the contact pressure and also the contact area. You know, one of the things I found in my days by working for Macintosh for a number of years was we used to do what are called amplifier clinics. And in the amplifier clinics, we'd put an amplifier up on a test bench, we'd connect it up to an oscilloscope, we'd feed a sine wave into it, and then we'd read it for distortion. Well, when we were connecting the speaker posts off the speaker connectors on to the load box, if we didn't tighten the connections really tight on the amplifier, you could actually see on the oscilloscope not only the primary sine wave, let's say we were at 60 hertz, if we're looking at that, but we'd also see harmonics. And they were a result of not having the contacts tight enough. As soon as we tighten them all down, the harmonics would disappear. And it all has to do with how good the contact is and how much surface area there is in the contact. So the contacts on the ground side of the RCA, as in all the connections, extremely important. On the XLR, something just a little different. Now we're using tellurium copper and beryllium copper for the same reasons, because we want that springiness on the female part, but we want the male part to be very strong and hard, so that when it goes in, it stays in contact, and the beryllium copper then has nice contact area around it. The other thing that we've changed is the position of the pins in the female side. So pins 2 and 3 are recessed, and pin 1 is forward. Now, pins 2 and 3 being recessed, that's the signal. That's the plus and minus of the balanced signal. Pin 1 is the ground. So whenever you plug in this connector, ground's going to connect first, and then the signal. Why that's important is because if you're connecting this in and the pins are all in the same position, and you hit one of the signal pins before the ground pin connects, you're going to get a boom out of the speaker. And it's been known to blow woofers and tweeters because of that particular thing. But with this type of connection, that never will happen, because the ground pin's always going to connect first, and therefore when the signal connects, there won't be any loud noises from connect and disconnect on the XLRs. Also notice we've changed the look of the XLR too, from a dark black XLR to this shiny kind of a gunmetal gray. Really pretty connectors. On the RCAs, on the Crimson RCAs, we did the same thing, tellurium on the center post and beryllium on the contacts. Notice, by the way, the arrow, the sleeves back, that's a sleeve, that's a metal sleeve that we put on each of the connector jackets, so that you can see what the actual direction is with an arrow. And you know, this kind of goes toward the cosmetics of it. And we see a lot of companies that have directional cables and they use heat shrink. Well, they use heat shrink because it's cheap and it's easy to put on, but to me it looks very amateurish. And I like our cables to really look professional. And these little sleeves that we put on with the gold arrow on it really look professional. They look nice. And of course it's directional because of the copper that we're using is directional. And we get it in a directional form, and we keep the directionality constant through. The XLRs also have changed, and the XLRs also are using that recess 2 and 3 with pin 1, the ground pin forward, tellurium and beryllium in the copper. So those are all the new connectors. And we've been very excited about these new connectors, how they look and how they sound. And speaking about looks, when you do the, inspect our cables, it's really phenomenal. The responses that we get back, especially from reviewers, when we send them cables and they have them for the first time, one of the first remarks they come back with is how beautifully they're made. They look the part. that these cables will perform up to their levels, what the cost of them are, they'll perform up to that level and beyond. But they'll also have the look of a cable that has that kind of performance and cost level. So when you hand these to a customer, they'll look at them and he'll say, wow, these are really made beautifully. So you don't have to apologize for any kind of sparsity in designs for some of the high-end cables that we see, that it's really hard to tell why they charge so much for cables that look like they were kind of made in their basement. So these cables are beautifully designed. Everything is made to fit. All the connectors are made to fit every cable that we make. Everything is proprietary. So here's the different cables. So on the Crimson side, the Crimson, we make single-ended RCA, balanced audio, subwoofer. Now, this is very unusual because we're probably the only company in the industry that I know of that the subwoofer cable is different from the standard audio cable. Most everyone just takes the audio cable and either rebands it or marks it as a subwoofer cable. This is not. This is totally different from the audio cable. Jay designed this cable as a low frequency audio cable, where the RCA is a full range audio cable. So the subwoofer cable is different. Of course, the digital audio cable is a 75 ohm cable, silver plated center conductor, lots of shielding. And that's one of the secrets to why it sounds so good also, is that shielding is spectacular. USB is only available on the Crimson side, and the USB again is heavy gauge conductors and lots of shielding between the power cables and the signal cables internally inside that USB. And there's also silver plating used there too. So that gives that cable, that's a fabulous cable. That was, comparison was done in Absolute Sound between that, which is a $200 to $300 USB cable, compared to, I think it was Kimber's $1,500 USB cable. And the comparison was very favorable. I think, who did that one? Neil Gator did the review, and he said that the value of the Crimson was much better than the Kimber was for the dollars, for what you get for the performance. Then we also make AES EBU cables, which are the balanced digital cables, 110 ohm. So they use XLRs on those, but that's 110 ohm cable. And then on the AQUA side, the Clarus AQUA side, we do all those same cables except USB and AES EBU is not available on the AQUA side, only on the Crimson side. Now for speaker connectors, we changed our speaker connectors. These are the new spade looks. They're made with tellurium copper, and they're spring type. It's actually a two-piece connector, kind of like that. So it's hinged at the back and it's kind of spread out at the front. And the reason for this is sometimes the amount of effort it takes to properly connect speaker wire to the back of a speaker can be a lot. And sometimes it can't actually be done all the way, can't be done completely. And I know I've tried it, and I found there are times on some speakers that have a connector tightening mechanism, like I think B&W for years had these round balls, and there was no way to grip it. So you can get the connector tightened. I tightened as much as I could, hand tighten it, and then I could just take the cable and move it, and it just fall right off. With this new connector, because of that spring, it's going to always want to push back on the connector. So as you're trying to tighten the connector back, it's wanting to push back. So there's a nice amount of force there. So when you do get it closed, it's going to be tight, and you're not, the cable, to move it, you really have to force it. So it makes a very strong connection, and a lot of the surface area then is impacted, and the pressure is there to make sure that's a great connection. So that's on all our speaker wire. Then the new banana plugs have the beryllium contact pins. So the new pins are all beryllium. So those are the new contacts on the new cables. We have a lot of these out for review, and we're waiting for those to be published. So here's the Clarus speaker cables, and we have these in a 2-to-2 or 2-to-4 bi-amp, or excuse me, a bi-wire, or a 4-to-4 bi-amp. We can do that in any of those configurations, and also in the AQUA. And you notice when you look at these with the speaker cables, notice how they're put together. You've got the speaker cable itself with the red and black or the blue and the black jacket, and they go into that block, that metal. That's a metal block, and that metal block is just a termination point for the regular part of the cable, and also it transcends it then into those black legs. Now those are actually silicon tubes that we had made special. We actually had to buy tooling for those. Those are silicon tubes that are made to cover the inside PVC covered conductors. So it has that nice uniform look to the speaker cable as it transitions from the block to the actual connector. It's not a multicolored wire. Notice also that we're not using any heat shrink anyway. And again, that heat shrink is not something that I approve of, and we use only materials that fit, so we don't have to use any heat shrink to accommodate non-fitting product. And here's our power cables. These cables we make them in two different models. A high current model for the Crimson side is an 8-gauge cable, and the standard or source model is a 12-gauge. And then we also make the AQUA series, and that high current is a 10-gauge, and the source model is a 14-gauge cable. And we also make this in a 20-amp version on the high current side for high current. And that one has a 20-amp IEC, and it also has a 20-amp 3-pin. So there are numbers of power cables that are out there today that have a 20-amp IEC, but a 15-amp 3-pin. I've never understood that. Why would you want to have a 20-amp? That denotes that the line that it's being plugged into is a 15-amp circuit, because if the receptacle's a 15-amp circuit, that means that it's 14-gauge wire, and it's designed for 15-amp. If you have a 20-amp amplifier that requires 20-amp receptacle, you should have a 20-amp. You should have 20-amp circuit to feed it. So we do 20-amp is true 20-amp, 15 is 15-amp. So all our cables are made here in Orlando. We get all those pieces and parts, and we do all the fabrication and all the assembly here. Now, the last part is the art of the demo. This is really an important part. It's just as important to know what all the technology is and the history of it. Demoing it properly is the important thing. And what I found in my experience in demonstrating, the best demo for any of these cables is the power cable. I'm not saying you shouldn't demo or you can't demo speaker or audio cables, that's for sure. But if you want to do a demo, just a quick demo for someone, and show them that cables do make a difference, power cables are the best way to do it. It's the easiest way to do it. Otherwise, you're trying to get behind equipment, and it takes too long to change speaker cable. If you're making a demonstration to an end user customer, their memory, audio memory is a few seconds. So if it takes 5 minutes to change all the speaker wires out, it's gone. You're not going to remember what he heard before. But you can do a power cord demo, change it in just a matter of seconds if it's set up properly. So you have a stock power cord, let's say, and then you have, let's say, a Clarus power cord, and you have the Clarus power cord connected to, say, a preamp or a processor, or even a DAC, standalone DAC, and listen to it for 30 seconds, and then stop the recording and have the stock power cable right next to it. So, all you have to do is unplug one, plug the other, hit play, restart play, and off you go. And the difference there, you'll have a customer saying, wow, hard to believe that a power cord can make that much difference. But it's a great demo. So I encourage you to use that in your store, and it will make a difference. You'll sell power cords, and you'll sell more regular cables too. And I'm always of the opinion that if you want to be convincing, you've got to be convinced. And if you haven't heard that demo, it'll convince you. So try it. I think you'll be very surprised if you haven't done it already. So reviews for Clarus cables are on our website at the claruscable.com//reviews.cfm. And there's a whole host of all the reviews that have been published. Now we have some new reviews coming. We have one from positivefeedback.com, Tone Audio, Soundstage, and the Audio Beatnik. These are all Clarus cable reviews of the Mark II cables. These are all completed. We've been notified they're completed, but they haven't been published yet, so we're waiting for that. We've also been in talks with Absolute Sound and Stereophile Magazine, and they have agreed to do reviews of our Clarus Crimson cables at some point, hopefully in the near future. They haven't given us a date, but they said they would be doing it. So we're looking forward to that. So thank you for your attention today and listening to the discussion on Clarus Cable. I hope it was beneficial for you. Any of you out there that are on the webinar that are not Clarus dealers that would like to become a Clarus dealer or would like to audition any of our products, please let me know. You can contact me at joe@claruscable.com or my direct line at work at my office, 407-447-2277. Call me anytime. And if you have any questions you'd like, or if you have any answers for me, that'd be great too. But questions are welcomed. That chat line is open. Or if you want to unmute your mic and ask the question, and your video, hopefully too, if you're going to do that. I'd like to see you and we can talk about it. Please do. Anybody? We'll hang on here for a few minutes and see if anybody has any questions. No, it doesn't look like it. Okay. Well, again, thank you everybody for joining it. Oh, okay. Well, let's see. We do have a question from Tom Altabelli at Woodbridge Audio in New Jersey. Oh, the hollow banana. He said the hollow bananas he found have been terribly unreliable. Tom, in what way unreliable? Are you talking about physically unreliable? Like they break? They break when stressed, even slightly. Wow, okay. We'll take another look at that. I didn't find that on ours, but I'll take a look to see. I know banana plugs, the BFAs, those can be touchy. I mean, it's a thin metal, and it has to be in order to maintain that spring. But it's such a great connection. We just tell you, just be careful. You can't really bend them. You can't put too much force on those banana plugs, but they do sound great, and they do make great connections. Well, thanks, Tom. I appreciate that comment. As soon as we get off, I'll go take a look at our stock and see what that looks like. But I have my recollection of them is that they seem to be pretty sturdy. Now, of course, this all depends upon the type of metal that's been used and also who's making them, who the manufacturer is. So that can have a bearing on it, but I sure will check it. And again, thanks for mentioning that. And let's see, everybody. Ed Sullivan's on. Eddie, thanks for coming on and joining with us today. I hope you got something out of this. Love to see you. Love to sell you some Clarus product. Love to have you selling our Clarus product. And Mark from Audio Video Therapy in New Hampshire, thanks for joining also. That was great. So again, any questions, anything you'd like to talk about, anything that comes up, please contact me anytime. If I'm here, I pick up the phone. So again, thank you very much, and hope to hear from you soon. Have a strong sell, guys. See ya. You're welcome, Mark. Okay.